So, hello students, and welcome back to yet another video on All India Rank Cartel, where rank is a ritual. In today's video, we are going to discuss a very important chapter that is thermodynamics, and this video is specifically for the Tamil Nadu Board students, also for the other board students, because the Tamil Nadu textbooks are very good. We'll cover this chapter very in detail, and after in this chapter you'll gain very important concepts like what is the difference between system and surrounding, what is closed system, what is open system, what is isolated system. Across have to understand that what is state function and what is path function. Then you will get the idea of internal energy, work and heat. Then different laws of thermodynamics you have to study, what is internal energy, what is enthalpy. Then you have to study about the calculation of the enthalpy changes. Then you have to move to the thermochemistry part where you will study the Hess law. Then you will define the condition of the spontaneous and the non-spontaneous process, and what are the spontaneous and the non-spontaneous process. And definitely you will going to study the thermodynamic functions for the spontaneity like Gibbs free energy. And in the same manner you will going to establish a relationship between the delta G and the spontaneity. So if we move to the chapter, then the thermodynamics, what does thermodynamics basically means? So a very beautiful definition is given that thermodynamics means flow of heat, and it derives from the Greek word thermos. Thermos means heat and dynamics means flow. In our daily life, we came across what many type of reaction where heat is transferred from one body to another body. But basically, if we look at the thermodynamics in a greater perspective, it is basically the study of the transformation of the energy from one form to the other form, which is very well mentioned in the uh, line. So thermodynamics basically is also the interaction of one body with the other. It tells us that the one body interacts with the other body uh, in form of work and heat. So there is an interaction between different bodies in the universe, and they interact basically in terms of what? They interact basically in terms of heat and work. So you can give different perspective regarding the thermodynamic chapter, but you have to remember that it is a interaction. It is an interaction between what? It is an interaction between system and surrounding, and how they are interacting. They are interacting in terms of work, and they are interacting in terms of what? They are interacting in terms of heat as well. So it is a very good to say that it is the study of the transformation of energy. Okay, and moving ahead, we will have to understand that what we are going to evaluate in this chapter. So there are many things we are going to evaluate, but basically we are dealing with the macroscopic properties like heat and work and their interrelationship. What is the macroscopic properties? Macroscopic properties means we are assuming that the properties are basically defined for the matter in the bulk and not for the individual atoms at the microscopic level. Always we are concerned about what? We are concerned about this whole matter, that is the aggregate of the matter in the bulk. And the whole formulation of the thermodynamics is basically based on the fact that the matter is basically does not consist of atoms and molecules. And that's why we are not bothered about what is the pressure applied by this one molecule, what is the pressure applied by this one molecule of the gas or the liquid or the solid. We are concerned about what is the overall the pressure, overall the volume, overall the different work, heat and everything. So we are basically dealing with what? We are dealing with the macroscopic level. And yeah, that is written here also, that the macroscopic properties of the system is independent of any theories or properties of the individual molecules which constitute the system. So we're not dealing with the microscopic part. The principle of the thermodynamics is basically based on we can say first law, second law, and third law. But we can say definitely the first and second law, the first and second law are very much fundamental laws. Remember, guys, the first and second law are very much fundamental. They are very much fundamental laws. Why we are calling the first law and the second law the fundamental law? Because they are fundamental in the sense that there are no there are no there are no process in the universe which violates this first and second law, which contradicts the first law of thermodynamics, which contradicts the second law of thermodynamics. And that's why I call the first law and the second law of thermodynamics as the fundamental law. There is one more law which deals with the calculation of the entropy at the 0 Kelvin, which we called as the absolute entropy can be calculated, because the entropy of the system at absolute 0 Kelvin, if the system is perfectly crystalline, will be zero. So the third law is dealing with the entropy. We'll learn further in the chapter what is entropy. So basically, this chapter is very much interesting, and we are going to enjoy this chapter. So this is the overall introduction. Ki what is thermodynamics? The thermodynamics is basically you can see the transformation of one form to the other form. Thermodynamics is basically what? Thermodynamics is basically the interaction of system and surrounding in terms of heat and work. And the whole thermodynamics chapter, we say, is basically talking about the macroscopic properties. And macroscopic properties are basically the properties which are defined for the matter and the bulk, and we're not concerned about that the matter is made up of atoms and molecules, and we are not talking anything at microscopic level. The whole thermodynamics, then we see that that is based on the formula, based on the basically three laws, but the two laws, the first law of the thermodynamics, the second law of the thermodynamics, is kind of fundamental. Why it is fundamental? Because there's no examples, there are no life examples, life process which basically contradicts the first law, which violates the first law, or which violates the second law, and that's why they're very much fundamental in nature. So we will study first about the system, what is system and what is surrounding. System is anything which is under our investigation, and the matter which is under our investigation, under our observation, is called a system, and the matter which is not under our investigation, the rest matter, is called as the surrounding. So the universe is basically divided into two parts, the system and the surrounding. This is under our observation, and this is not under our observation. And this is the boundary. This boundary can be real or imaginary. This boundary can be real or imaginary. Okay. Itself, our universe, we're going to see that our universe is itself a system. Itself, it is a system. And which type of system is this universe? So this universe is basically a type of what? We will see it is a type of isolated system. It is a type of isolated system. So this is very important, that universe, in the book it is written that a system and surrounding are the part of the universe, but itself the universe is an isolated system. Now we have multiple examples of the system, like water in a beaker, balloon filled with air, an aqua solution of salt, an aqua solution of glucose, and many other system we have. The system called homogeneous if the physical state of all of its constituents are same, like a mixture of gases, because every phases are in the gaseous phase. Okay. A system is called heterogeneous if the physical state of all its constituent is not the same, because some are gases, some are liquids, some are solids. So these systems are called as what? Heterogeneous systems. And you can say that the mixture of oil and water, is can be easily called as the heterogeneous system. But if we talk about the homogeneous system, it is a mixture of gaseous and completely miscible liquids. They are called as the homogeneous system. Surrounding is the not the part of the system is called surrounding. We already discussed. The boundary is basically the thing which separates system and surrounding. And let's start with the types of the system. So one is open system, one is closed system, and one is isolated system. In open system, basically, you have to remember the key point. What is the key point, sir? The key point here is it is a system where the matter can be exchanged. The matter can be exchanged, the heat can be exchanged. when there is a matter exchange, possible, and also the heat exchange possible between the system and surrounding, then such system is called as open system. And if we talk about a closed system, you you have closed the system, but the heat is allowed. The heat exchange is allowed. Here, the heat exchange is allowed, but there is no matter exchange allowed. Between what? Between the system and surrounding. There is no matter exchange. I'm making a cross here because there is no matter exchange allowed between the system and surrounding. An isolated system, basically this wall that we have kept here, it is basically an adiabatic wall or an adiabatic boundary. And what is the feature of the adiabatic boundary? It does not allow the flow of heat. So you can say that the isolated system is the system where you cannot going to exchange the heat between the system and surrounding, and you cannot going to what the matter exchange is also not possible. And we can say that the universe is very excellent example of what? Very excellent example of the universe. Okay, so you read and you get the idea, because I am giving you a very important key points which you read and also understand that that it is a very simple thing. Then moving to the next thing, that is the intensive and the extensive properties. If we talk about the intensive and extensive properties in thermodynamics, remember that intensive properties are those properties which does not depends upon the size of the system, and extensive properties are those properties which are depending upon the size of the system. So it is size dependent properties, and this are intensive are size independent properties. Okay, what are the meaning of size dependent or size independent? Because if we divide a system in smaller parts, so the extensive property, the value of the extensive properties will change if we divide the systems. But the value of intensive property will not change if we divide the system. For example, the volume is an extensive property because as we divide the system, the volume becomes, suppose we are making a partition at the middle, so the volume becomes V by 2 and V by 2. So the volume changing, if you're changing the system, if you are dividing the system, the volume is going to change. The volume is becoming V by 2 and V by 2. So we can say that the volume is an extensive property. Volume is an extensive property. But what about the temperature? The temperature first is T, but still after partition, the temperature will going to be T and T. So we can say that the temperature is going to be intensive property, as on division of the system, the temperature does not changes at all. So this is the mass or size. We can here it is also mentioned the property with depend on mass and size is called extensive property. There are many examples: volume, number of moles, mass, internal energy, even all the thermodynamic parameters like delta H, delta S, delta G are definitely the extensive properties. Even heat capacity you will learn in the chapter is also an extensive property. And refractive index, surface tension, density, temperature, boiling point, freezing point, molar volume, specific heat capacity, specific heat capacity. Okay, the molar heat capacity. There is more example like vapor pressure. Yeah, it is mentioned here. Vapor pressure, you can add vapor pressure, pH, like EMF. I'm giving extra example. These are also what? Intensive property. And enthalpy, entropy, free energy, heat capacity are basically extensive property. Many examples can be given in the intensive, like you can say that the concentration terms are intensive property. Now look at one thing. Density is what? Density is an intensive property, and it is basically what? It is basically equal to mass by volume. And what is mass? Mass is extensive. Volume is also extensive. Okay. Now look at one more properties like molarity. Molarity is what? Number of moles by volume. What is number of moles? The number of moles is an extensive property, and volume is also an extensive property, and molarity is an intensive property. So you can say that the ratio of two extensive property, the ratio of two extensive property, the ratio of two extensive property is always is always is always what? Is always an intensive property. It is a very important point that you should know before your examination. But the vice versa is not true. And the vice versa is not true. And the vice versa is not true. Means the ratio of two intensive property need not to be extensive in nature. But the ratio of two extensive property is 100% going to be what? Is 100% going to be extensive in nature. So this is the part that you have to understand very well, because from this part a question generally comes, and you have been asked which of the following properties are extensive and which of the following properties are intensive. Now moving ahead, and we will understand the thermodynamic process. The thermodynamic process basically brings the change in the state of the system. And by what kind this change can be, what are the type of these processes which brings the change in the state of the system. We can do cooling, heating, expansion, compression, fusion, vaporization. There are multiple things, there are multiple processes which can bring the change in the state of the system. So thermodynamic processes are basically bringing what? They are bringing the change. Change in what? They are bringing the change in the state of the system. They are bringing the change in the state of the system. Now, there can be different thermodynamical processes, but overall, in an umbrella, we can call these processes as reversible process and irreversible process. So, reversible process in simple language, you have to understand that it is those processes where system as well as surrounding retains original states. They retains original state simultaneously. They can retains original state or initial state simultaneously, and that is the reversible process. And what is the other point that you have to remember? Reversible process takes infinite time to for completion. It takes infinite time for completion. It is very slow. It is very slow. Here the system and surrounding always remain in equilibrium with each other. And the pressure difference between the system and surrounding is very very less. Okay, so there is you can say that यहाँ पे it is written that it is infinitely slow process, and the system and surrounding remains equilibrium with each other. Also, reversible process are not real process. They are what? They are hypothetical process. They are hypothetical process. They are not real process. They are slow process. They are sudden process. Also, you can see that these are also called as what? These are also called as quasi-static process. Why we are calling it as a quasi-static process? Because you're not able to see any changes. You're not able to observe the dynamics of the process, because the process is very slow. It is undergoing change. The system is undergoing change, but the change is very slow. The change is taking infinite time to execute, and that's why you are seeing that the process is basically static. That's why we are called reversible process as a static process. For example, you want to get a feeling of the reversible process, just take a cylinder and attach a piston in the cylinder. Okay. And just put a sandbag over this. Just put a sandbag over it. Here it is a sandbag. Here it is a sandbag, and you want to do what? You want to do a reversible kind of expansion, though it is not 100% possible. But still, if you want to execute a nearly reversible process, just put out one grain of sand and throw outside, and do it one, other, then third grain, then fourth grain, and there are. Then the process is basically what? The process is slow, and because as soon as you put one grain out of the sandbox, the pressure above the piston becomes what? It becomes P minus dp. The pressure above the piston becomes what? It becomes P minus dp. What does P minus dp? The pressure above the piston becomes what? P minus dp. P minus dp, and the piston pressure inside is P. So there is a slight very dx amount. The piston will move upward, So this process you have to execute for your lifetime. That picking one grain out of the sandbag. So this process, in this process, what you are observing, the system and surrounding, there are very little pressure difference between the system and the surrounding. They are at nearly what equilibrium position. Okay, and as soon as you see it, there is basically very static nature of the process. That's why we call it a quasi-static process. Other important things about reversible process is that it is highly efficient process. This reversible process are highly efficient process, highly efficient process. Why I am calling it highly efficient process? Because when we want to attain the when we want to obtain the work from the system, then the system performs work, and if it's performing the work in the reversible manner, we obtain a greater output of the work. So in the later of this chapter, like in the second law of the thermodynamics, we will understand, and in the first law also we will understand the work obtained from the reversible process by the system is maximum, and that's why it is highly efficient process. The rest is the irreversible process. The irreversible process is the system and surrounding cannot be restored to the initial state from the final state, and it is called as irreversible process. Because if the system is restored to the initial, like you press a bottle and you release the pressure, the system retains the initial state. But we will prove in the later stage that the system and surrounding does not retains the original state simultaneously. And there are irreversible processes are very what they are very fast and sudden process. They are very fast and sudden process, and you can say the system and surrounding does not remain in equilibrium with each other, because the system and surrounding are basically what they are basically a large pressure difference between them. So they are not in equilibrium with each other. And there are many other properties like irreversible process are not, and they are real life process. They are what they are real life process. They are real life process, fast process, sudden process. That takes place at constant pressure. That takes place at constant pressure. They takes place at constant pressure. So if you want to understand which process is irreversible, then you have to understand that irreversible process takes place at constant pressure. Fast process, sudden process, system and surrounding does not remain in equilibrium with each other, and it is also less efficient process. Means the work output that is coming out from the system is less. And we will going to prove this also. Don't worry, we're going to prove this also. Then we have other processes also, like we have adiabatic process. Adiabatic process is the process in which you have isolated system, and the heat exchange between system and surrounding is what zero. And for the adiabatic process, you can say the q is zero. And many other things we are going to understand later in this chapter, like what is adiabatic expansion, how the adiabatic expansion is going to be done. Because before the first law of thermodynamics, it is very the thing is written that the work is done by the system, its temperature decreases, means adiabatic expansion causes cooling. If the work is done on the system, its temperature increases, means adiabatic compression causes heating. But these, you can understand these points by after studying the first law of thermodynamics. So I'm not explaining it right now, but it is very adiabatic process. First, you know it. You need a what? You need an isolated system, and the heat exchange between the system and surrounding is zero. Such processes are called as adiabatic process. Later in this chapter, we will see that for the reversible adiabatic processes, the PV to the power gamma will be constant. Okay. And what is gamma? Gamma is a Poisson's ratio. So later in the chapter, you will understand what is gamma and how this relation comes. So this is the adiabatic process. Isothermal process. If we talk about isothermal process is basically those process where the temperature remains constant. Means dt is equal to zero. For the isothermal process, dt is equal to zero. Such processes are called as isothermal process. Isobaric process, dp is zero. Isothermal process, dp is zero, means pressure is constant. In isochoric process, dv is zero. And what about cyclic process? The cyclic process initial and final state are same, and for this the state function, the value of the state function will going to be what? Zero. Like the value of du will be zero, the dh value will be zero, because state means the initial cyclic process. For the cyclic process, initial and final states are what? Same, and that's why the value becomes equal to zero. And what is the state function? Which depends upon the initial and the final state of the system. Like what is this state and what is that state? It is P1 V1 T1. It is P2 V2 T2. Now, if we go to state A to state B by this path, by this path, by this path, the value of state function will not change. It does not depends upon the nature of the path. It will remain same. And if we talk about the path function, like work done is a path function. Work done is a path function. It depends upon which path we are taking. If we want to go to Delhi, we can go by train, we can go by bus, we can go by train, rickshaw, we can go by our we can go by walking also. So in each case, we are doing what? Our legs are doing what? Different kind of work done. Because, and therefore, the work done is definitely in chemistry, in thermodynamics, is a path function. It is not a state function. Okay. And so there is a pressure, volume, temperature, internal energy, enthalpy, and free energy. They are called as what? State function. And path function is the path, the process which depends upon the nature of the path, like work done and heat are called as path function. Okay. And later in this chapter, we will see the how the internal energies are defined. But let's keep this keep this lecture one till here to revise, and we will meet you in the next class in lecture 2 of the thermodynamics. And also, after watching this lecture, please comment that I have watched the complete lecture and I have made the notes. And also mention your name if you're watching it from Tamil Nadu or Andhra Pradesh or Telangana or from any part, because this lecture is, I have taken it from the Tamil Nadu textbook, but it is very important for every students, every English medium students. And if this video gets more than 100 likes, the lecture 2 will be coming today or the tomorrow morning. Thanks a lot for watching this video till now, and we will coming with the lecture 2 of the thermodynamics, in which we are going to discuss about the internal energy, the first law of the thermodynamics, and the whole Tamil Nadu textbook will be covered in a very lucid manner. Thanks a lot and have a nice day. Jai Hind, Jai Bharat, Vande Mataram.